Hello everyone! In this lesson, we will continue to study the basic knowledge module. Today, we will study system model and its classification. The main content includes the definition and representation of system, basic unit used to describe system, and the classification of system. First, let's review the definition of system. System refers to a whole with specific functions. It can be regarded as a signal converter or processor. The mathematical model of system refers to the abstraction in mathematics of the physical characteristics of system. This is a RLC series system. If the voltage UC on the capacitor is used as the solution variable of the circuit, the mathematical model of the RLC series circuit can be expressed by Formula 1. This is a second-order differential equation, and it is the mathematical model of the RLC circuit. When we only focus on the input and output relationship of the system, or the relationship between motivation and response, as well as the function of system, the system can be represented by several blocks. Each block can represent a component with a certain function, and can also represent a subsystem. In this way, the system can be represented by a block diagram. The basic units describing system are as follows: adder, multiplier, scalar multiplier, also called number multiplier or scalar, differentiator, integrator, delay unit, and delayer. Let's take a look at adder. This is the graphic symbol of adder. In such a two-end adder, the output of this adder is y. Yt is equal to f1t plus f2t. This is the graphic symbol of multiplier. The output y of multiplier is equal to f1t times f2t. Scalar multiplier or number multiplier or scalar can be represented by figure A or simplified to figure B. Its output y is equal to A times ft. In general, A can also be called gain. Next, differentiator. The output of differentiator is the derivative of the input signal. In the same way, the output of integrator is the integral of the input signal. Delay unit is a basic unit used in a discrete system. Yk equals fk minus 1. The relationship between the output and input of delayer yt is yt equals ft minus big T. Here is an example of system block diagram description. Please use integrator, scalar, single adder to draw a system block diagram of the system represented by the following differential equation. This is a second-order differential equation. First, keep only the highest derivative term of the output at the left end of equation. Since it is a second-order differential equation, we put d to the power of 2 times yt over d times the square of t to the left. The rest terms are placed to the right of the equation, so we get the formula 3. Integrate formula 3 twice, we can get formula 4. After the left side is integrated twice, it becomes yt, and the other terms correspondingly become primary integral of yt, quadratic integral of yt, primary integral of ft, and quadratic integral of ft. In this way, formula 4 can be described by the system block diagram. Let's take a look at Formula 4. The left end of the Formula 4 is yt. It can be regarded as the output of an adder. And the right side includes 4 items. It can be regarded as 4 inputs of a single adder. According to this principle, we can get figure 1, system block diagram of a single adder. Let's look at this adder. The output is yt. It is exactly the output of this adder. This adder consists of 4 inputs. One of the inputs comes from the first order integration of ft, and it enters the adder after it is integrated twice. Ft enters the adder after first order integration, which is expressed by the last 2 terms of Formula 4. In the same way, the adder enters the input after the first integration of yt and scalar reverse, and adder enters the input of the adder after the second integration of yt and scalar reverse. That is the first 2 items in Formula 4. In this way, it is easy for us to understand the relationship of a block diagram composed of a single adder and its original differential equation. Let's take a look at Formula 2, the original differential equation. Formula 4 is obtained through the transformation of Formula 2. So, Formula 2 and Formula 4 are equivalent. Figure 1 is a block diagram of the system, which consists of a single adder, integrator, and scalar. Let's look at how to use 2 adders to implement second-order differential equation. Formula 5 is a general expression of second-order differential equation. Such a second-order differential equation can be described by the system block diagram with 2 adders in Figure 2. These 2 adders are the adder at the input end and the adder at the output end. The input of the adder at the output end is from xt, and x equals t times b1. Here, xt is a variable we get to get the input and output relationship of the system block diagram. Similarly, the output of the adder at the input end is x double equals t. The input is ft. X equals t enters the adder after a1's scalar reverse. xt enters the adder after a0's scalar reverse. If you want to find the input and output relationship of a given system block diagram, you should mainly write the left-hand adder. That is to say, you should write the expression of the input adder. If you want to write the expression of the input and output relationship of the right-hand adder, you need to set a variable xt, then cut off its intermediate variables. Then you can get the relationship between ft and yt. Let's compare the previous Formula 2, second-order differential equation, with Formula 5. Obviously, here a1 is 3, a0 is 2, b1 is 1, b0 is 1. With such a relationship, if we know a second-order differential equation, we can directly draw the system block diagram with 2 adders. Let's talk about the classification of system. According to different mathematical models, the system can be divided into real-time system and dynamic system, continuous system and discrete system, linear system and nonlinear system, time-varying system and time-invariant system, or non-time invariant system, and so on. Real-time system refers to a non-memory system. Generally, it is expressed by algebraic equation. Dynamic system refers to the memory system. It is generally described by differential equation or difference equation. Continuous time system is described by differential equation. Discrete system is described by difference equation. Most systems in the engineering are composed of different systems, so they are all hybrid systems. According to the previous analysis, there are the following classifications of system: linear time varying system, linear time invariant system, non-linear time varying system, and non-linear time invariant system. In extra engineering, there are also causal system and non-causal system. If a system responds at t equals 0 and t is relevant to the input when t is less than or equal to 0, it is called a causal system. Otherwise, it is called a non-causal system. In other words, the output of the causal system always lags behind its input. This course focuses on linear time invariant system or LTI system under the action of deterministic signals. This class is over. Thanks for your listening. Goodbye.